All right, so we are going to go ahead and talk about partial derivatives using a couple examples from chapter 14. So starting with example number 3, we're asked to find the partial derivatives with respect to x and y with the point 1, 2, right? So in order to do that, we first have to find just the general partial derivatives with respect to x and y. So I'm going to start there, and I thought about kind of how I might explain this if I was explaining this to students. Pretty much, if we're, taking the derivative, partial derivative, with respect to x, I might think about, if I copy this back down, if I'm taking the derivative with respect to x, I'm not necessarily ignoring y, but I'm considering y to be almost just like a constant. So, maybe it helps to just pretend those are some sort of numbers, and then how would the derivative act if y was just considered a number, and we're really just deriving, with respect to x. So in that case, if I just pretend those are numbers, we end up with 3x squared, just from our basic rules of derivatives. And then here, because y is just a number, again, I'm not ignoring it, I'm still keeping it there. I'm going to derive just in general, becoming 6x, but y is still there, because let's say that was just the number 2, 3 times 2, that number wouldn't just disappear, right? For our last case in this right-hand value, we can see that there's no x's in that value, right? Meaning this would just be a number. We know that if you take the derivative of any constant, you end up with nothing, right? 0. So we don't need to write anything down for that. Now, in this specific case, we really want to find what happens if we plug in 1, 2, right? So this would be a pretty basic case of just plug in 3 times 1 squared plus 6 times 1 times 2. And what do we end up with? 3 plus 12, so 15. So that was evaluating our first partial derivative with respect to x. So our second one, which would be derivative with respect to y, is going to be a very similar process, except if we're thinking about kind of, what might be happening here. Again, I'm going to copy this down just so we can take a look at kind of what's happening. Respecting with y, taking the derivative with respect to y, I want to pretend that all these x's are now just numbers, right? If those are numbers, this first value disappears. If we end up taking the derivative, it ends up as 0. In this next piece, we end up just keeping x squared as a value. If you derive anything that's just, the basic value y, it would be whatever values are in front of it that would become the derivative, right? For example, if it was 2y, your derivative you'd write down would be 2. But in this case, our values, our constants in front, are 3x squared. And then we get our second piece, which is just a y squared, so minus 4y. And then finally, in this case, we want to plug in 1, 2. So 3 minus 4 times 2, so 3 minus 8, equals -5. So that answers kind of our second piece of partial derivative with respect to x, but plugging in the point 1, 2. So kind of one way that we might see this applied would be in that example. So for our second piece, number 5, very similarly, we're going to find the partial derivative, partial z over partial x, and then partial z with respect to partial y. In this case, we're really going to take the derivative, in generally speaking. I'm going to write down z first, just to kind of have this look a little bit clearer for us. It's x squared plus x minus y to the 7th power. Okay, so if I want to find dz dx, I'm going to take a look and, it looks like I'm going to have to use my power rule, right? I'm going to have to take my 7 to the front, x squared plus x minus y to the 6th power. But then, using our chain rule, we got to make sure if we're deriving with respect to x, I'm going to take the derivative of this inner piece with respect to x. So again, not ignoring y, but in this case, because y would just be a constant, we really kind of have to essentially ignore y. So we end up with 2x plus 1, because we get x squared, 2x, and then the derivative of x would just be 1, right? Because y is a constant, it'd be plus 0. This really ends up being our answer. You might reorganize things to make them look like in increasing order, but in general, that's what we're looking like. So for our second piece of our answer, we're going to look very similarly, because if we are deriving partial z, partial y, we still have the same kind of concept happening here. The power rule, right? Okay, except now if I'm doing dy on this bottom piece, I'm going to derive with respect to I, or with respect to y. So I'm going to take all these x's. These are just numbers. There's no y's next to those x's, meaning the only piece I have here, the derivative of negative y, would be negative 1. So in this case, it might make most sense for us to write negative 7, and then x squared plus x minus y to the 6th power. So these would be our two separate answers for number 5, our partial derivatives. All right, thank you for listening.